All right, hey, what's going on, guys? We just got done with seventh block, and I said, you probably don't need another video. We have enough of these freaking videos, but we didn't get a chance to talk about all the homework problems. I figured I'll just go through them, and you can skip using the bookmarks, right? I'll tell you what time during this video I'm talking about each problem, but I figure maybe you can watch a few that potentially looked like we needed more discussion on if we did get them in class. Okay, so please watch at your own time. This is a question that I talked about during third block here. I'm not going to talk about it much, but just pointed out, this is just, it's supposed to remind you this question here that, right, check it out. We know that those two things are supplementary, right? Because it makes a straight angle, right? Measuring a 1 plus measuring a 2 equals 180. And if this is a parallelogram here, right, we would know that segment QP is parallel to segment ST by definition of a parallelogram, and that these are corresponding angles right here. Check it out, right? So we know that angle P is congruent to angle 2. So the purpose of this problem is just to remind you that, let's erase all this stuff here so we have this here, that when you have consecutive angles, right, consecutive angles in a parallelogram, okay, they are supplementary, right, supplementary. Add to 180, okay, because again, right, we get this adds to 180. 110 plus 70, 180. 110 plus 70, 180. So angle 1 plus angle 2, 180. Angle 1 plus angle P, measure angle P, is 180 here, okay? Because, right, they're corresponding angles. So that's just another way of looking at that. That was in the exit ticket yesterday, that consecutive angles of a parallelogram are supplementary. That's not a theorem in your textbook, but I'm going to give you the approval to use that in a theorem. Or sorry, a proof of a new theorem, if you would like, because it's perfectly logical, okay? These are same side interior angles too, right, that are cut by a transversal PT, and these two lines are parallel. Those add to 180. That's another way of thinking about it, okay? So remember, consecutive angles in a parallelogram are supplementary, and then, right, angle Q plus in angle 1, look, they're both obtuse, they actually are congruent to one another, okay? So consecutive angles in a parallelogram are supplementary, and then opposite angles in a parallelogram are congruent, okay, are congruent here. So that's the thing you need to remember. All right, check it out down here. That's going to help us with a little bit on congruent angles for number 7. Not really interested in how the opposite angles there. And let's see if we can critique what they're doing down here. So it looks like they found numbers 5 and 6 correct. So that was nice. Okay, they got the definition of a parallelogram. It's actually going to be the first two letters. The last two letters, those would be non-intersecting because W and X are the endpoints, Y and Z are the endpoints. They got different endpoints. They're not going to touch. So WX and YZ is parallel, and then also ZW and XY, right? 4 distinct letters. That's sort of the trick there that you got. All pairs of congruent segments, good work on this one. We got the opposite sides, WX and YZ. And then we got the other opposite side, XY and WZ. They got that right there. But then they also have the diagonals got bisected. So they have XO and OZ's got to be the same through the fact that diagonals of a parallelogram bisect each other. And then definition of a midpoint would be that O must be the midpoint. If O is the midpoint, XO equals OZ, and so on and so forth. WO and OY, same thing. Okay, so that one's good to go. So I forgot to put the check marks down on this one, but this one's good to go. This one's good to go. Here's where it got a little bit tricky was name all of the pairs of congruent angles. There are a lot, right? There are a lot here. Okay, so let's go through them one at a time. The ones they tried to say, and this is inaccurate here. I tried to say this in class. That's inaccurate because here, W is the vertex of angle X, WO, angle OWZ. See how I'm saying the W in the middle? W is the middle letter used. And it's also the vertex in angle XWZ. So when there's more than one angle shown, adjacent angles that are sharing the same vertex, right? Adjacent angles shown, or just if they're two angles that share, they don't have to be adjacent angles. If they're two vertical angles, for instance, they would share the same vertex. You need to name at least 3 letters, or really just 3 letters, 1 letter on each of the rays of the angle. Hopefully that makes sense to name the angle. So instead of saying W and Z and Y are congruent, X and Z are congruent, I see what you're saying. We want to say that this, right? You're trying to say this, that opposite angles in a parallelogram are congruent to one another. You're trying to say that. So it's a lot easier visually to say that and say that this isn't angle X. This is angle YXW. Okay, YXW. So I'm being specific here. Y is a point on this ray, XY, and W is on the point of this ray, XW, that make up the sides of this angle, okay? So angle X means nothing to me there. There are 3 angle X's shown there, but actually there's 0, right? Because we wouldn't call them angle X. There are 3 angles that share a vertex, a common vertex of X, so we can't name it just through one letter. That's vague, right? That's vague. So you're not going to use the one letter thing on number 7. We can use it up here, right? Because contrast that with angle P right here. That's the only angle shown in the diagram that uses point P as a vertex here. Okay, so anyways, I digress here for that lesson right there. Angle YXW here is going to be congruent, so that's the X here, and then the Z's here, so that we're going to use that. It's congruent to angle WZY. Okay, so big things is here, we got the Z and the X there, right in the middle, okay, and they're congruent to one another. We also know that opposite angles of a parallelogram, we got 2 pairs of opposite angles in a parallelogram, so we're going to know that angle XWZ congruent to angle, oops, what's the angle symbol there? Angle ZYX. Okay, and here, right, we can get those 2 angles. So opposite angle parallelogram congruent, that's that reason. But there are more congruent angles in the diagram. It says name all pairs of congruent angles in the diagram here. So just know that you're gonna have a lot of angles problems when it comes to diagrams here because they're also vertical angles. Vertical angles are congruent. So here, look at that. Those are vertical angles. We know those are congruent. So here, vertical angles congruent. We're gonna know that angle XOY congruent to angle ZOW. We're also gonna know this, boom, 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 boom. Angle XOW congruent to angle ZOY, okay? So now we're up to 4 pairs of angles. If you remember from class, we actually had 8 pairs of angles, I said. We can find 8 right here. We can find 8 here. What are some other ones you had to do in this problem set? Well, that comes by virtue of the fact that a parallelogram is defined as a quadrilateral where opposite sides are parallel. When you have parallel lines and they're cut by a transversal, right? Ooh, look, the diagonals are a transversal of these. Look at this. This diagonal here I'm talking about is a transversal, and that diagonal, I guess, too, is a transversal of both diagonals, transversal of these 2 parallel lines. So what I can say here is I can get alt interior angles. So those alternate interior angles are going to be congruent because those 2 lines that got crossed by the transversal are parallel to one another. So what I'm going to know is this. Super messy diagram. That's why I'm doing this in different colors. Okay. So I'm gonna have to go up to 4 tick marks here. So what I'm gonna do this is that angle and that angle are alternate interior angles. Look, they alternate sides of the transversal and then they're on the interior of the 2 parallel lines. So I'm gonna get angle XYO congruent to angle, so XYO and angle ZWO. Okay, we're up to 5. I can get another pair of congruent alternate interior angles by using these 2 parallel sides, and that's these ones up here. 2 tick marks, 2 tick marks here, and that would be angle YXO, congruent to angle WZO, and then I'm also going to get this here too. I will also get over here, maybe I'll actually change colors right here, and I'll do this, still doing alternate interior angles. I'll maybe get these ones, because I'm going to use these parallel lines, right? By definition of parallelogram, and my dog howling, there he goes. Okay, that angle and that angle, alternate interior angles. Man, diagrams. Dealing with diagrams is just like, it's gonna be hard to see this stuff. Do you see it? Do you follow it? That kind of thing. How are you gonna see it? How are you gonna follow it? XWO congruent to angle ZYO. And finally, last but certainly not least, my favorite angles in this diagram. What does that even mean? Do this, and this, because those are also alternate interior angles. Here's my transversal. Okay, there are my parallel lines. This alternates sides of the transversal, and they're on the interior of the 2 parallel lines. Those are alternate interior angles. So we have here angle WXO congruent to angle YZO, and we're good to go. We got 8. There are 8 of them. Okay, there are 8 of them. Maybe I'll cross this out. Sorry, I apologize to you guys here, group 3. I hate to make an example of you. No, I'm just joking here. All right, group 4. Nice work here getting this one here. I would agree that's quadrilateral. That's not a parallelogram. It looks like a kite to me. So I would agree that like this looks like these are some 60-degree angles and 60-degree angle there. Well, I don't know actually about that. It's a kite. Yeah, if it's a kite, then I don't think your diagram's the best here. Because if it's a kite with two 60-degree angles, those angles would have to be congruent, and then it would be proven to be a parallelogram. So this is, what I'm trying to say is this looks like not a parallelogram, but hey, those two angles are the same. Oh, yeah, no, this is good to go. Okay, so maybe I'll enlarge their diagram. I think this looks good. So I'll enlarge their diagram of I think what they were thinking here. And please email me if you're not sure. Oops, that looks like a rhombus, which would be a parallelogram. Okay, so let me go back to it. Go back to this here. Boom, boom, boom. So they're not saying that these top and bottom angles are the same. I think what they're saying is this, right? And this, like those could be like 140 degrees. And look at this here. This is definitely not a parallelogram. So this is kite technically, right? This could be 130 degrees, 130 degrees, and then this could be like 40 degrees, and then this could be 10 degrees, right? 10 degrees there, okay? So this would be, it has two 60-degree, oh, they said 60-degree angles. So yeah, there and there. No, so this diagram is not good because 60 degrees is acute, right? So the acute angles here could be different. It can't be the same, right? These obtuse angles could be the same if it's a kite. Anyways, trapezoid is probably what you're thinking of. Maybe probably what some people are thinking of is what I'm trying to say. That's this example here. So we're going to have some quadrilaterals that have a couple of congruent angles, but aren't parallelograms. So for instance, let's think of maybe a trapezoid. What about this? Okay, this looks like about 60 degrees, right? There's an equilateral triangle right there. So that's about 60 degrees. This is about 60 degrees, okay? And is it a parallelogram? No, it's a trapezoid. So yeah, it doesn't necessarily have to be a trapezoid too. Like this could have cut down like that, and then it's like just not anything special at all. But there's your example right here. So actually, let me get rid of that because I can't actually prove that. Okay, so they didn't do justification for this one. Number 8, number 9, they didn't justify. They got this one right after a little bit of feedback from good old Mr. Fortin here. But so yes, all angles are congruent. That's not enough to really justify this. Okay, so you got to explain here that right this and this are congruent. So HG. Oops, sorry, HG parallel to GF, and we can prove this. We can prove that. We can also prove that. GF. Oops, sorry, HG and EF. That's what I meant to do. EF, GF parallel to HE. Because if two lines are cut, this is back from chapter 2, you prove this, cut by a transversal and corresponding angles are congruent, then lines are parallel. Do you have to say all that in your answer? No, you don't have to say all that in the answer. You can just say that corresponding angles are congruent. Corresponding angles are congruent, and that's going to pave the way for us knowing the lines have to be parallel to one another because there's that postulate from chapter 3, okay? So this is definitely, you can prove that pair of lines congruent because you have corresponding angles that are congruent. You can prove that pair of lines are congruent. So we have these two angles are corresponding angles. So we would know that they're congruent. Okay, this one right here, no, the angles are not supplementary because, right, same side interior angles or consecutive angles don't add to 180 degrees, okay, to 180 degrees here, okay? This one is going to be no as well, okay? So this one is no because opposite angles are not congruent, and we're done there. And there we go. And we're good, right? Are we good? I don't know, we're good. All right, we got that one there. All right, let's keep going. Keep justifying, keep on working. Excellent work there. Hey, they had some questions about this here too. This is kind of a weird question. I went over this third block. I didn't have time to go over fifth block. Didn't have time to go over your block, seventh block. But this section here had a fourth theorem, which your exit ticket didn't have you write down. But it was in the lesson video. Hopefully you wrote it down. Hopefully you read it. We'll go over it again in a second. But the idea is a ladder is kind of like having two parallel lines next to one another, okay? Two parallel lines next to one another. So the question of this is a ladder. If you're building a ladder and you place two like metallic like columns, I guess, that are parallel to one another, okay, how would you have to construct the rungs of the ladder, right here, rungs of the ladder? And if you're building it, are all the rungs going to be the same size? Well, I got parallel lines right here. Rungs of a ladder, are they all congruent to one another? And why would they be congruent to one another? So let's maybe think about this, because this has you kind of pose on something that you haven't really thought about so far yet. So here, this is a corollary here that the idea of the question, here's the answer to the question. The only reason why I included this one is because your problem set didn't have anything about this corollary. And it does come up a bit later, so I want you to kind of remember this, if possible. I know there's a lot there to keep track of, right? But that's what this is kind of all about, is making arguments, keeping track of things, and incorporating those older things into your arguments here. So this is a corollary I want you to remember. It kind of helps you think about this ladder problem. But the idea is this. If you have two parallel lines, right? We have the ladder maybe like this, two parallel lines. And the points on those parallel lines are equidistant, each point here. So maybe I'll draw it on this here. I'll get parallel lines, right? Let's pretend the ladder's this way. Okay, if I knew that these lines were parallel, there is a conclusion that you're now able to make, because we talked about this as a proof, okay? And it works just like a ladder. If I have a point here, point A and point B, I know that those lines are equidistant. Those points are equidistant from the other parallel line. Okay, other parallel line. And you might be thinking, that's pretty obvious. I got two parallel lines. They're going to be the same distance away from one another. And you might be thinking that, and that's great. But the idea is, have you proved that yet? Did we prove that until this section? And the answer is no, right? The answer is no, because all we have for parallel lines right now, so you have to ask yourself, like, well, I know that about parallel lines, but it's like, did you prove that yet, right? Do you actually, because you want, as a mathematician, you want to have a deductive proof for as many claims as you have, as much information you have. And finally, we have a deductive proof, because we talked about it here. The proof is written out as a paragraph proof for us. But anyways, right, that's what I'm talking about right here, a little paragraph proof example. Yeah, I mean, you walk to somebody on the street, you ask, tell me about parallel lines. What are two pairs of, what is a pair of parallel lines? The person might say, like, why are you asking me that? That's ridiculous. But also math, oh, what the heck? But then they might say, okay, parallel lines, those lines that are always the same distance from one another. And you as a geometry student should probably say no, right? No, they're not. Sure, they're the same distance from one another, but parallel lines aren't defined as such, right? Parallel lines are defined in chapter 2 for us as lines that are coplanar and not equidistant, coplanar and do not intersect, okay? That's all we have for parallel lines. Now we have some more information about parallel lines. What do we know about parallel lines? Well, now that we know about parallelograms, okay? Now that we know about parallelograms, that this point here and this point here, sure, we know that they're two lines. They don't intersect, right? That's the definition. We know that that point and that point, same distance from this other line here. So if we have a line P and a line L, okay, the points on line P are going to be the same distance from line L. So then you got to ask yourself, how do I measure distance in geometry? How does distance get measured? And I reviewed this with third block. I had time to do it with them. So I have time to do it with the other classes. Distance is measured from a point to a line is this. What kind of a segment did I draw in? What kind of a segment did I draw in? So from a point outside the line, I can draw exactly one perpendicular segment. Perpendicular segment, okay? So just a quick reminder that distance, right, from a point to a line is the length of the perpendicular segment drawn from that point to the line, okay? So I'm allowed to introduce that. From a point outside of the line, exactly one perpendicular can be drawn. So I've drawn that in. And now, check this out. In the middle right here, we got ourselves a parallelogram. That's a parallelogram right there. And it is, and we can prove it. Because at the beginning of this, we got line P parallel to line L, right? I'm going to put my parallel symbols right there, okay? I'm going to give them over here, right? Let's make it parallel. So I know that side AB and side, let's make this XY, are parallel to one another of this quadrilateral that got formed here. But our question is are these distances going to be the same? We need to prove this is a parallelogram. And how can we prove it's a parallelogram? Well, I drew in a perpendicular here and a perpendicular here, and check it out, right? There's a whole ways we can prove this, but that angle is congruent to that angle, right? if two lines are each perpendicular to the same line, they are parallel to each other, okay? Because they would each form right angles here, and all right angles are congruent to one another because they measure 90 degrees, okay? So if two lines are each perpendicular to the same line, they are parallel to one another. That's another theorem, wordy theorem that came up earlier, okay? So now we have a parallelogram, right? AX parallel to BY, and we have AB parallel to XY. So that means that this is a parallelogram right here, okay? What do we know about parallelograms? This is why you can finally prove this freaking thing right now. We know that opposite sides of parallelograms are congruent, and so those perpendicular segments we drew in earlier, congruent to one another. So we know, ultimately, what we just proved is this. If two lines are parallel, then all points on one line are equidistant from the points on the other line. Those perpendicular segments are going to be congruent. So now we can actually say that. That's some information that's proven that any point on one line is going to be the same distance from any parallel line than any other point on that line. Kind of wordy, right? But just proved out. And we needed parallelograms to prove that fact. Okay, so now we know more about parallel lines, which is kind of nice. Okay, so what this extends itself with ladders is this, right? A ladder is just going to be two parallel lines here. What's going to be true about all those rungs of the ladder? Those are called rungs. Well, if we arrange them in such a way that they're perpendicular to both of the rungs, they're all going to be the same length, right? They're going to be the same length. So if I got two parallel lines and a whole bunch of perpendicular segments that are all the same length, then that means that if I got two parallel lines, what would follow logically is just if I got parallel lines, then all those points that are being connected are going to be the same distance away. Okay, so that equidistance. So it's kind of a wordy problem, kind of weird, but none of your other problems in that problem set dealt with this. So that's the reason why I wanted to include that on the homework. And I was just like, what is this? What is this here? Okay, anyways, now that I went over that. Okay, good work here. This is some algebra problems. I did number 16. I did that as a video, okay? So there's another video that I have. If you didn't watch it before doing the homework, hopefully you watched it here. Okay, excellent work on this proof. This one looks good to go. Awesome, you've named all the angles because you needed to name these vertical angles, right, as 3 letters. So this is an angle X right here. This is angle CXA. They named it there. This is angle FXD. They named it there. Good to go. Whereas angle B, there's only one angle B, right? Only one angle B, so that's good to go. And angle E, that's good to go. And excellent work here. Good job on that one. Good job on all these. You guys are doing great here. Okay, showing your work. Another one that I did a video on was number 22. So if you need more explanation on problems like these, I go through number 22 slowly for you, so you can maybe see it as an example, okay? And finally, oh no, this is me finally, this is the final thing I explain right here will be this, but check it out. This proof here, this is another one. There's another video, right? A video, and it's directly on the classroom assignment that you did for the homework yesterday. It's the whole proof is explained here, but they did a great job of doing it too. I don't know if they did it all on their own, but idea of this was, yeah, you could figure out that if this is a parallelogram, right? We got that parallel, and that's this side QT parallel to RS. We would know that these are parallel, but then we'd also have alternate interior angles congruent here. We would have vertical angles congruent here, vertical angles congruent here. And then check it out. This is a diagonal here, so we know that that's congruent to that. That doesn't help us, but this helps us here. That is congruent to that. So through ASA, those two triangles are congruent, and CPCTC, right? We would know that that here is congruent to that here. And that's sort of how the logic of number 28 works. I like that. I think it's smooth proof. I'm trying to congruent. Okay, number 23. I got 5 minutes until reg, so hopefully I'll wrap this up really quickly just to go over this. You guys didn't show your work, so I'm just like probably had questions on it. In case you want to know how to do it, so you're given that this is a parallelogram, okay? Angle 1, angle 2, angle 3. You don't need to know angle 2 because check it out. If this is a parallelogram, right? Angle 1 and angle 2, we don't know if they're congruent to one another or not, right? We don't have enough information. It looks like angle 2 is bigger than angle 1. But what we do know is that angle 1 is congruent to angle 3. And we know that because by definition of a parallelogram, KDEC, KD would be parallel to CE. So these are parallel lines cut by a transversal. Look at that transversal. That line is cutting these two parallel lines. So alternate interior angles are congruent, okay? So what we got here is measure of angle 1, right? Here it's got to be congruent or equal to measure of angle 3. And so what we can do is we can take that, the algebra that represents this here. You're not going to need to know how to solve a quadratic for your quiz because that's sort of a late Algebra 1 one, and I'm not really reviewing it for you in a full way, but you might as well know how to do this. It'd be nice. Measure of angle 1 is 4x, and measure of angle 3 is x squared minus 60. Okay, you might be wondering, how can I get x? How can I get x here? The key to solving quadratics is actually isolating the quadratic, meaning getting the whole quadratic expression equal to 0. So in this problem here, I got to subtract 4x here. I'm going to subtract 4x here. You might remember this from Algebra 1, you might not, but like you'll get it reviewed in Algebra 2. So 4x minus 4x is 0, and then x squared minus 60 minus 4x, that's good too. But I like to order the polynomial correctly, which is largest exponent to smallest exponents. This is x to the second power, this is x to the first power, and this is technically x to the 0th power, right? X to the 0th power is 1. But anyways, we get rid of that here. Okay, so now x squared minus 4x minus 60 equals 0. You can use the quadratic formula in this one, but you can also factor it, right? So I'm just going to do it quickly. I'm not going to review factoring for you. This here is actually equivalent to, right? I brought my 0 over here. My 0 is here. 0 is here. I can rewrite this actually as x, and then we got to find two numbers that multiply to negative 60 and add to negative 4. That's a little shortcut that you may have learned in Algebra 1 here. I'm not going to go over the shortcut. So my answer here is going to be negative 10 and 6. Okay, it's 6 here. So now I got factors. So now you might have learned in Algebra 1 the zero product property. I got to get numbers that x equals, that's going to make the whole quadratic equal to 0. So if x is 10, right, if I put 10 in there, right, 10 minus 10, that equals 0. And so if this factor is 0, multiply it times that makes the whole equation 0. So basically 10 is the solution to that equation. Another answer here is, oops, if I put in negative 6 to this equation, negative 6 plus 6 is 0, that's another solution, negative 6, okay? So we don't care, in geometry, you don't care about the negative values because x can't be negative because you can't have a negative angle measurement, right? You can't have that here. So what you care about is the positive. So here, x equals 10, and then finally, measure of angle CED is 70. And the way I can get that is CED is this. Oh, here's where angle 2 comes into play. Angle 2 is congruent to angle TED because they're alternate interior angles. And then again, these lines are parallel here, okay? So here, measure of angle CED would just equal 1 plus 2, which is this, okay? So it would be 7x, and 7x equals 7 times by 10, and that equals 70. Okay, so that's where that 70 came from. All right, rewatch that in case you want to watch that. Email me if you have any questions. 1 minute till reg. I'm going to go ahead and hit stop on this. Thank you for your amazing effort. Do the best you can. And thank you for putting up all these answers. And I'm glad I got a chance to go over some. Sorry that I can't just do it magically really quick in class. Okay, take care, guys. I will talk to you soon. Bye.